Okay, class, we're about to start lesson 11, multiplying polynomials. Now it says multiply a monomial by a monomial. So that's basically saying one term multiplied by one term. And it basically goes like this. You will multiply the two numbers together. So 2 and 4 is 8. You will multiply the like variables together. Now you notice A is by itself. So you will bring down A. But we have a B here and a B here. So what you would do is you would write B down once, but you would add their exponents. The exponent of B here is 1, the exponent of B here is 1. You would add them and you would get B squared. Okay, we will go more in depth with that as we go through the practice problems. Now, multiplying a monomial by a binomial. So basically what you would do, you would take the one monomial and multiply by each individual term of the binomial. So negative 2z squared will multiply by z, and then negative 2z squared will multiply by the 3yz. And we will cover this in once we get to the exercises. And multiplying a binomial by a binomial, I will get to that before we actually go through using the FOIL method. So let me go and do some problems here. Okay, so I may do considerably more problems with this than I did in the previous lessons on 10. So let's go ahead. So number 1, it says multiply the monomials. So you have 6x times 5x. Now listen, this is going to be one of the few times that I do this. These x's, the exponent of these x's is actually 1. When you don't see the exponent, you know that those exponents are supposed to be 1. So now we multiply. 6 times 5 is 30. X times x, we bring our x, but we add the exponents. So it'll be 1 plus 1. So our final answer would be 30x squared. So I'm showing you how we did the addition. Now I want to get to, let me do number 2. Number 2, we have 2xy times 3y. Now again, these x, you see that we don't show any exponents with these variables. They're assumed to be to the first power. So 2 times 3 is 6. There's only one x here, so we'll bring the x down. Y times y will give us y squared when we add those exponents. Now, let's look here at number 3. Number 3, we have 7abc times 4bc. So we'll do 7 times 4 is 28. There's only one a, so we bring it down. B times b is b squared, and c times c is c squared. Okay, number 4. So number 4, we have 12y times z. Now, remember, whenever you see a variable and there's no number in front or it doesn't look to have a coefficient, we know that coefficient is 1. So that's really 12 times 1, which is 12. And y and z are not like variables, so we just bring them down. So your answer is 12yz. Okay, number 5. Number 5, you have a times 9bc. Now, if you notice here, this is basically the same as number 4. First of all, you have no like variables, and then you have a number times a 1 that's not shown. So this would be 9abc. Okay, number 6. We have 5xyz And then we have 2x y squared z to the 4th. So now we multiply. 5 times 2 is 10. X times x is x squared. Y times y squared is y cubed. And z times z to the 4th is z to the 5th. Because remember, when you have the same base, you add the exponents when you're multiplying. Okay, now, number 7. We have 4ab times bc squared. Now, we have 4, that would be 4 times 1 is 4. We only have a here, so we'll bring down the a. B times b would give us b squared, and then we only have a c squared, so we bring that down as well. So that's it for problem number 7. Problem number 8. We have 17f squared gh cubed multiplied by 2fh to the 4th. So 17 times 2 is 34. F squared times f, we had f, and then that'll be 2 plus 1 is 3, so it'd be f to the 3rd power. We only have 1 g, so we bring it down. H to the 3rd times h to the 4th will give us h to the 7th, because 3 plus 4 is 7. So that took care of problems 1 through 8. Now we come down here from 9 to 16. Now we're going to multiply the binomials by the monomials. So let's look at number 9. Number 9, we had 3z squared times 6xy plus 4z. Now we're basically doing a distributive property. We have a monomial with one term multiplied by these two terms. So we have 3z squared times 6xy plus 3z squared, and we put a plus because the 3z squared is positive, times 4z. So 3 times 6 is 18. And then we put it in alphabetical order. This would be x, y, z squared, because none of the variables have the same base. Now, we take 3 times 4, which is positive 12. Z squared times z is z to the 3rd power. And they are not alike, so this will be our final answer for number 9. Okay, number 10. We have 6x times 7x. Wait a minute, I wrote that wrong. We have 6x times 7x minus 6z. 6x, so we have 6x times 7x, and then a positive 6x times a negative 6z. 6 times 7 is 42, and x times x is x squared. 6 times negative 6 is a negative 36, and then we will have xz. And this is your final answer, because they have nothing else in common. Okay, now, we look here at problem number 11. Problem 11. We have negative 5ab times 3b plus 11c. So we'll take negative 5ab times 3b, and then negative 5ab times 11c. So negative 5 times 3 is negative 15. We only have one a here, and b times b is b squared. Negative 5 times 11 is a negative 55. And then here, we have a, b, and c. None of them match up, so it'd be a, b, c. So this right here is your final answer, because none of these have anything in common. So we're done with that. Now we move on to problem 12. So problem 12, we have negative 3f cubed times 6h minus 8fgh squared. So we had negative 3f cubed times 6h and negative 3f cubed times a negative 8fgh squared. Negative 3 times 6 is negative 18, and that'll be f cubed h. Negative 3 times negative 8 is a positive 24. Then f cubed times f is f to the 4th, gh squared. And there's nothing more we could do with this. So that would be your final answer for number 12. Now 13, we have 10z times 7x to the 7th minus 5z. So we had 10z times 7x to the 7th plus 10z times a negative 5z. So 10 times 7 is 70. Z times x to the 7th will be x to the 7th z. And then 10 times negative 5 is negative 50. And z times z is z squared. That here is your final answer because they have no like terms. Okay, now we go here to problem 14. Problem 14, we add negative z times negative z minus 6xy. So we add negative z times a negative z minus z times a negative 6xy. Negative z times negative z is a positive z squared. And negative z times a negative 6xy will be a positive 6xyz. And that's it for problem 14. Okay, now problem 15. We had 8b times the parenthesis of 9ab plus 8a. So now we add 8b times 9ab plus 8b times 8a. 8 times 9 is 72. Bring down our a and b is b squared. Plus 8 times 8 is 64. And b times a is ab. And we're done. They have nothing else in common. Okay, now 16. We add negative 9 times negative 2x to the 4th plus 3xy squared. So we'll take negative 9 times negative 2x to the 4th, and then negative 9 times 3xy squared. So negative 9 times negative 2 is positive 18, x to the 4th. Negative 9 times 3 is a negative 27, xy squared. They have nothing else in common, so we're done. All right, now with C, it says multiply the binomials by using FOIL. Remember to complete by combining like terms wherever possible. Now, I'm going to teach you what FOIL is, but I prefer to say using the distributive property, but you will see that later. So let's look at number 17. We have x plus 5 times x minus 6. Now, this is multiplying a binomial by a binomial because we had two terms here. Remember, terms are only separated by addition and subtraction. So we had two terms here and two terms here. Now, with FOIL, you are supposed to take, FOIL is an acronym. Okay, so the acronym is FOIL. Now I'm going to write this down off to the side, and you can copy this in your notes. So I'm going to take this other sheet of paper here, and what I'm going to do, because you will have it in your notes, I will talk about it, but again, you will have it in your notes. So FOIL, FOIL. This stands for front, outer, inner, last. Again, write that down. FOIL. F is front, O is outer, I is inner, L is last. So pause that, copy this down, and then we can continue on with problem 17. Okay, now, the first letter of FOIL is F, which stands for front. That means that we will multiply the first two terms of each parenthesis. So we have x times x. Now, the next, the O, outer. So we would take the first term of the first parenthesis and the last term of the second parenthesis. So this is a positive x, so it'd be x times negative 6. So this is front, outer. Now we're going to do inner. So that's inside here. We'll multiply this plus 5 and the x. So it'll be the second of the first parenthesis and the first of the second parenthesis. That's the inner. Now we do last. Last is the last of each parenthesis. So it'll be plus 5 times negative 6. So again, FOIL, FOIL, front, outer, inner, last. Now, if you need to rewind that to listen to it again, feel free. But now that we have everything set up, now we can multiply. X times x is x squared. X times negative 6 is a minus 6x. 5 times x is 5x. And 5 times negative 6 is negative 30. Now we combine the like terms. We have x squared, negative 5x plus 5x will be minus x, and then minus 30. And this will be your final answer for problem 17. Now, we go on to problem 18. Problem 18, we had x plus y times x plus y. X plus y times x plus y. So now, again, we do the FOIL. Front, that'll be x times x. Outer, that'll be x times y. Then we do inner, that'll be y times x. Then we would do last, y times y. Front, outer, inner, last. So x times x is x squared. X times y is xy. Y times x, we'll write it in alphabetical order. It'll also be xy. And y times y is y squared. So we have x squared. Xy and xy will give us 2xy when we combine the like terms, plus y squared. That took care of problem 18. Now we go to problem 19. So we have z plus 9 and z minus 9. Now again, we do the front, which will give us z times z. The outer, which will give us a positive z times negative 9. The inner will give us positive 9 times z. And then the last will be positive 9 times negative 9. So this will give us z squared minus 9z plus 9z minus 81. So we have z squared. The negative 9z and 9z will simplify out to 0. And we'll bring down our minus 81. So that took care of problem 19. Now problem 20. Now 20, a little lengthy, but not too bad. Problem 20, we have yz squared plus x. And then we have yz squared minus 3x. So our front will be yz squared times yz squared. Our outer would be a positive yz squared times negative 3x. And then our inner would be positive x times yz squared. And then our last would be a positive x times a negative 3x. Now I ran out of space, that's why I have it stacked like this. So now we multiply yz squared times yz squared is y squared z to the 4th. Because remember, we add the exponents. When you add the same base, you add the exponents. Now we will have minus 3xyz squared. And then here this will be plus xyz squared. And then this will be minus 3x squared. Now we combine like terms. We have y squared z to the 4th. Negative 3xyz squared plus xyz squared will give us a negative 2xyz squared. And then minus 3x squared, because it's no more like terms for the 3x squared. So that is the final answer for problem 20. All right, now we go here to problem 21. Problem 21. Three x plus 3 and 3x plus 5. So you add 3x times 3x plus 3x times 5 plus 3 times 3x plus 3 times 5. Now, I did my front, my outer, my inner, and my last. So this would be 9x squared plus 15x plus 9x plus 15. So it would be 9x squared plus 24x plus 15. That'll be it for problem 21. Now problem 22. Problem 22, we had x plus y times x minus y. Okay, so now we would do x times x plus x times negative y plus y times x plus y times negative y. So this will give us x squared minus xy plus xy minus y squared. So we have x squared minus xy, and positive xy will simplify out to 0, and we'll bring down our minus y squared. So it'll be x squared minus y squared. All right, now 23. We have y squared minus 6 and y to the 4th plus 10. So again, we do our FOIL. Y squared times y to the 4th plus y squared times 10 minus 6 times y to the 4th minus 6 times 10. So this would be y to the 6th plus 10y squared minus 6y to the 4th minus 60. Now if we look here, there are no like terms, so this is our final answer. Okay, problem 24. We had AB plus 3. We had AB minus 4. So you add AB times AB plus AB times a negative 4 plus 3 times AB plus 3 times negative 4. Okay, now we're going to go through and multiply. This will give us a squared times b squared. This will give us negative 4ab. This will give us a positive 3ab. And this will give us negative 12. So it'll be a squared b squared, negative 4ab plus 3ab is a negative ab and minus 12. And that is your final answer for problem 24. Now, we have problems 25, 26, and 27. It says choose the one best answer to each question. Which of the following expressions is equal to this here? So, let's go here to problem 25. Problem 25, we have 4a cubed b squared times 3a squared c. So we multiply. 4 times 3 is 12. A cubed times a squared is a to the 5th. And we'll bring down our b squared and c because they have none of these that have the same base. So we add 12a to the 5th b squared c, and that is a. So for 25, our answer is a. Okay, now we go here to 26. Martha has 2pc squared board games, and John has 6p squared c board games. Which of the following expressions represents the product of the number of board games that Martha and John have? Now remember, product means multiplication. So that means that we would take, for problem 26, we'll take 2pc squared times 6p squared c. So 2 times 6 is 12. P times p squared is p cubed. C squared times c is c cubed. Because remember, when they have the same base, you add the exponents. Okay, so we got 12p cubed c cubed, which is d. Okay, now 27. It says which of the following expressions is equal to, so we'll do 4ab plus 2 times 3ab minus 7. So we would do the FOIL method. So we have 4ab times 3ab plus 4ab times negative 7 plus 2 times 3ab plus 2 times negative 7. So 4 times 3 is 12, a times a is a squared, b times b is b squared. 4 times negative 7 is negative 28, ab. 2 times 3 is 6, and we have our ab. And 2 times negative 7 is a minus 14. So we add 12a squared b squared, negative 28ab plus 6ab will be a negative 22ab. And then minus 14. So we had 12a squared b squared minus 22ab minus 14, which would be b. And this right here is the final problem for lesson 11. I will upload this to YouTube. Have a wonderful day.